Alright guys, welcome here to the second half of the video. Number 25, we're starting here. Plot triangle RST with R1, R2, and then perform the following composite. So, you have the first triangle located here, and then you see do x minus 4x plus 2, so back 4 plus 2 for all of them. And that takes you to that. Reflect over the x-axis. So then you take the points that are 2 away and you go 2 down, and then the rest, and you go here. There'll be patty paper available, and you'll also have the rules. I mean, everything you need will be provided. 26. So this one's kind of hard to show you on here without patty paper, but it says a trapezoid is in the third quadrant of the coordinate system here. The trapezoid is reflected across a line y equals x, then is reflected over the x-axis. Which of these transformations will put it back in its original position? So basically we want to get back to what you see now after you do a reflection with it. And the reflection is going to kind of make it sit like this, sort of. And so basically, whatever you do, you want to be able to get it back to look like that. Well, a clockwise rotation of 90 degrees, number one, is exactly that. We normally do clockwise, which goes, counterclockwise, which goes to the left, but one to the right, 90 degrees, will put it back where it belongs. And it does line up like that. So that's checked. Reflection across the line y equals negative x, then a reflection across the y-axis. So the line y equals negative x, let's see. Y equals negative x is this line here. So if you flip it over, you'll have the kind of long end here and the slanted at the front, and then you reflect it over y, and it goes right on top of that. So that one works. And then a reflection across y equals x, and then the x, that's kind of the opposite of this. Y equals x is the line that goes that way. So you reflect it over, it goes up here, and then over the x-axis it goes down there. So again, really difficult to show these without patty paper, I think, but they all do work for what it's worth. Patty paper will be the most help there. 27, a land developer is dividing a tract of land into triangular shaped parcels. The triangles are equilateral and have sides equal to 100 yards. He finds it is more efficient to make the parcels larger. He triples the length of each side. What will be the perimeter of the parcel? Pretty simple problem. Equilateral with all sides of 100 would be 300. If you triple all the sides, that makes it 300, 300, 300. You'll get 900. Also, because perimeter is one-dimensional like length, you could literally have taken the perimeter of the first one, 300, and multiplied it by 3. It's the same thing. 28. The endpoints of segment PQ are -4, -4, and 0, 0. So that's plotted here. Under a composition of transformations, the image has endpoints at 6, 7, and 2, 3. So it winds up here. What two transformations could accomplish this change? There's a few of them. I put rotate 180, which flips over here. Q stays at the origin and goes out, and then you would have to move over 2, up 3 to get there. You could also accomplish this with a reflection over y equals negative x. And then the same one, which one? So what you can't do, because of the position of the letters, the points, don't translate first. Like, you can't just go up and over and line it up that way, because Q is going to wind up out there, right? So usually a reflection or the rotation to turn the letters around, and then a translation. 29, describe the series of transformations that get you from the first figure to the last. Similar to the problem in the front, and this one, 3 and 4 were supposed to be different. We forgot to change it on this. So you see it there. It's pretty straightforward. All right, next page. All right, circle M is shown below. Chords KH, HI, and IJ are congruent. What is the measure of KHJ? So again, the key here is that at L, you have an inscribed angle. That's half the arc, so we double the angle, you get the arc KJ. KHJ, if you follow it, is the rest of the circle. So 360 minus 270 is 288. Now, for what it's worth, those individual chords it talks about, let me come back here and erase this stuff for a second. Because the chords are congruent, you can see here with the kind of red lines, that the arcs above them are congruent. So KH, HI, and IJ are all congruent as well. And if you needed to find individual measurements, you could divide the 288 by 3. This question doesn't ask it, but just throwing that out there. 31, the endpoints of the diameter of a circle, Z are A and B, negative 5, 6, and B, 1, 2. What are the coordinates of the center? What is the length of the diameter? So first, AB, you plot them, or you just use the points and you do midpoint. And you get the center at negative 2, 2, which I plotted there. And then distance formula, which is on your blue chart. x2 minus x1 squared plus y2 minus y1 squared, all under the square root. And you get 10. So, pretty straightforward there. 32, find the value of x. This time, unlike the front page, this is a quadrilateral in a circle. Opposite angles equal 180, so you see it there. X plus z is 180. Y plus z is 180. W plus y is 180. You add them up, set them equal to 180, combine like terms, and solve. And you can see the algebra there to work those out. (33) Circle C with a diameter DG is shown in the figure below. To the nearest 100 centimeter, what is a sector? So, DG is a diameter, cuts it in half to 180. This is 90 because you have the box. This is 20. 90 and 20 is 110. 180 minus 110 is 70. And then area of a sector, you plug it in. 70 over 360 times pi times 8 squared equals 39. Whoa. 39.10, but put the calculator. A game show is a giant circular spinner divided into 15 congruent sectors with a diameter of 24 centimeters. Pretty much again like the spinner one we did a couple pages ago. Since there's 15 congruent sectors this time, 360 divided by 15. Diameter is 24, so radius 12. Arc degree over 360 times pi times radius squared. Describe how the area of a rectangle will change if width is doubled but its length is halved. So I did an example here with length and width, as you see, where the length was originally 10, the width was 4. So the length was half, the width was doubled. 10 becomes 5, 4 becomes 8. Either way, you get an area of 40. The idea without actual numbers is length times width. You get 1/2 length, 2w. When you multiply 1/2 L times 2w, the 1/2 and the 2 cancel, and you still get LW. So again, it stays the same. A square has side lengths of m feet if one pair of opposite sides are doubled and the other pair of opposite sides are tripled. What would be the new area of the quadrilateral? There was one like this on the test with x. The key here, that what most people miss, is don't forget when you multiply 2m times 3m, the m's multiply together, and you get m squared. So most of you will get 2 times 3 is 6. A lot of you will leave it as 6m. It should be 6m squared because the m's multiply together. So basically the area would be 6 times as large because of the 2 times 3. All right, another page down. Let's keep going. Find the area of the regular polygon. 1/2 apothem times perimeter. That formula is on the blue page. Apothem is 5. It's like the radius. 13 times 5, because there's 5 sides, is 65. So 1/2 times 5 times 65, 162.5. John owns a piece of rectangular land that is 20 miles by 30 miles. If he cuts down the side of the land by cutting each dimension in half, what would be the area of the new tract of land? So there's a 30 by 20, gives you an area of 600 square miles. If he cuts everything in half, 15 by 10, that's only 150. So the new area specifically would be 150 miles, but notice that 600 to 150 is not cut in half. That's cut to a fourth, right? Because that 1/2 scale factor gets squared for area. Whoa, what's that? Not that. 39, quadrilateral PXTU is a rectangle, and each quadrilateral UCXD is a rhombus. Find the area. So over here you have 10 and 4, which means this has to be 6, which makes that 6, which makes the whole top 16, because the bottom would be 16, and 8. So 16 times 8 is the area of the whole rectangle. Then for the rhombus inside, you can treat the rhombus like a parallelogram, because it is. And so even though it's super leaning, it has a base of 10 and a height of 8. So 10 times 8 equals 80, and you subtract that. For what it's worth, the way this doesn't work all the time, just this particular picture, you literally could have also just found the area of the two shaded triangles by themselves. 1/2 6 times 8, or there's two 6 by 8s, which, they make a rectangle, it's 48, right? Either way. Find the area of the regular polygon. Yes, you can do, 6 times 6 is 36. Easy way to get there, but just to put the regular polygon, there's not going to be a question like this set up on the test, at least I don't think so, with the square, because you could do 6 times 6 and then the regular polygon doesn't matter. The idea is, here's your apothem, that's 3. 6 times 4, the perimeter is 24. You use the area, the regular polygon formula. But, it works either way. 41, Janelle is creating a mold to make candles. She wants to make cylindrical candles in the shape with a diameter of 10 and a height of 20. What would the volume be? Volume of a cylinder is area of the base times height. So you need the radius, which you cut the diameter in half to 5. The height is 20. So pi r squared times height. It does say leave in terms of pi, so I did radius squared times height, 500 pi. Find the surface area of the following pyramid. Surface area of a pyramid is 1/2 perimeter slant height times slant height plus base. There's a square base, so the perimeter is 4 times 4 times, which is 16. The area also happens to be 4 times 4, so one of the few times perimeter and base are the same. Slant height is 7, so 1/2 PL plus B, and you get 72. Find the surface area for the following composite. So there's a hemisphere, so 4 pi r squared divided by 2, so 4 pi times 6 squared divided by 2 is 226.2. Now, there was a problem like this on the test a lot of people missed. With surface area, if the side or the face, the base of the shape isn't shown or is covered, that's not part of its surface area, because surface area is intended to be the outside. So in a cylinder, even though there's a circle on top and bottom, the top circle here is covered by the hemisphere, so it's not outside. So notice, and that's why it's circled or boxed here in red, you have 2 pi RH plus 1 pi r squared, because the top base is covered. All right, so 2 pi RH for the lateral part, plus the 1 circle on the bottom. Even though it's on the ground, it is outside of the shape. So that gives you 263.9, and then you add them together, 490.1 centimeters squared. 44, a box measures 7 centimeters wide, 14 centimeters in length, and 4 centimeters in height. It should be the height is doubled to 8 to produce a larger box. Which phrase accurately describes that? So that's what I did. I literally just show you here. Here's the volume. 7 times 14 times 4 is 392. Double the 4 to 8. 7 times 14 times 8 is 784. And that's literally double. You can divide them, and it's just 2, right? So it just doubled. Even though we've talked about volume being three-dimensional, because only one of the measurements changes, you're only changing one dimension, so it is just doubled. All right, 6 pages down, 1 more to go. Let's finish up here. These last 3 questions come from previous tests, and we've covered them recently, so they should be pretty well remembered. The manufacturer of shaved ice cups made the new cone on the left. The radius of the old cone was on the right, but the height was not changed. How much did the volume increase? So the picture and the words didn't match up. There was a typo there, so cross out quadrupled. We went from a 1/2 inch radius to a 1 inch radius. And I just made up a height of 10 because, 10 is an easy number to plug in there. So volume of a cone is 1/3 base times height. So with first the radius of 0.5, you get 1/3 times pi times 0.5 squared times 10, which is about 2.62 when you round it off. Then for the cone with the 1 inch radius, you have 1/3 times pi times 1 squared times 10, which is about 10.47. When you divide that, you get about 3.9986, which in essence is 4 because you rounded off the decimals, and that's what changed it. But basically, it's increased the volume increased by 4 times. And then the last 2, which hopefully should be easy because we just covered this, probability. What is the probability of picking a 5, not replacing it, and then picking? It should be a king of hearts, not a kind of hearts. Right? There's all kinds of hearts. There's 4 5s in a deck of cards, right? There's a 5 of clubs, 5 of spades, 5 of hearts, 5 of diamonds. But a king of hearts, there's only 1. So on top of not replacing it, there's 4 to 52 the first time. You take out the whatever 5 you pick, and you're left with 51 cards and 1 king of hearts. So 4 times 1 on the top, 52 times 51 on the bottom. Just put in the calculator, it'll reduce it to 1 over 663. And the answer choices on problems like this will be reduced fractions, so just let the calculator do that. 47, a bag contains 5 yellow, 3 white, and 2 purple tiles, or 2 purple tiles and 8 green. So that's a total of 18 tiles. What is the probability of drawing a green tile and then a yellow if they're not replaced? So first, there's 18 tiles with 8 of them green, so 8 over 18. You didn't replace the green one, so you're left with 17, and there are 5 yellow. So 8 times 5 is 40, 18 times 17 is 306, and that reduces to 20 over 153. All right, that was a long 2 videos of a review, but again, the good news is the test is only 35 questions, all multiple choice. So hopefully after getting through this, it should be easy. So no more shout-outs on review videos for the rest of the year. Good luck, and we'll see you next week, and then we'll be done with everything. Bye-bye.